Start. Now, our question is Bayes-Servat's law. But before going to start, what is Bayes-Servat's law? We know that in 1820, Oersted performed a series of experiments, and from these series of experiments, he showed that a current carrying conductor produces magnetic field like same as that generated by a bar magnet, but Oersted failed to find the magnitude and the direction of magnetic field produced by a current carrying conductor. This limitation was overcome by Bayes and Servat, two physicists who successfully find the magnitude as well as direction of of magnetic field produced by a current carrying conductor. This Bayes and Servat's law, it is the basic law of current, electricity and magnetism. Suppose हमारे पास एक conductor है. Let's suppose that conductor is X and Y through which current I is flowing. Due to the flow of current I, a magnetic field is produced by this current carrying conductor. Now suppose we want to find magnetic field at point P due to this current carrying conductor XY. This point P is at a distance R from this conductor XY. So we can say this point P is called as point of observation. How we can find the magnetic field produced by this current carrying conductor XY of infinite length at point P? Well, first of all, what we have to do? We have to divide this conductor XY into small elements, and let us suppose one such small element is AB जिसकी length जो है that is equal to DL. क्यों हमने कंडक्टर को डिवाइड किया स्मॉल एलिमेंट्स में? सो दैट इन दैट वेरी स्मॉल एलिमेंट द करंट रिमेन्स कांस्टेंट. व्हेन करंट रिमेन्स कांस्टेंट, वो डेफिनेटली वी कैन फाइंड द मैग्नेटिक फील्ड प्रोड्यूस्ड बाय दिस स्मॉल एलिमेंट. दिस प्रोडक्ट ऑफ करंट एंड द लेंथ ऑफ एलिमेंट इज कॉल्ड एज करंट एलिमेंट, एंड दिस करंट एलिमेंट इज अ वेक्टर क्वांटिटी whose direction is same as that of the direction of flow of current, and it is the basic source of magnetic field. Like electric charge is the basic source for electric field, and current element is the basic source of magnetic field. तो मैंने कंडक्टर XY को डिवाइड किया है स्मॉल एलिमेंट्स में. एक एलिमेंट लिया मैंने AB जिसकी लेंथ DL है. We want to find magnetic field at point P which is at a distance R from the small center of element, and let us suppose this theta, it is the angle between the current element and the line joining the center of element and the point of observation. This Bayes and Servat found that the magnetic field produced by the small element, by the small current element at point P is dB is directly proportional to current I. यानी कि जितनी करंट ज्यादा होगी उतना ज्यादा मैग्नेटिक फील्ड होगा at point P. So we can say dB, it is the small magnetic field produced by the small current element directly proportional to I. This dB, it is directly proportional to dL, where dL is the length of element AB. dB, it is directly proportional to sine of theta, where theta is the angle between the direction of current element and the line joining the center of element and the point of observation. And this dB is inversely proportional to square of the distance from the center of element to the point of observation. Well, these 4 points are commonly known as Bayes-Servat's law. Now, when we combine equation first, second, third, and fourth, we get dB directly proportional to I dl sine theta divided by r square, where I is the current, dl is the length of small element, theta is the angle between the direction of current element and this line joining the center of element and the point of observation, and r is the distance from the center of element to the point of observation. Now, we have to combine. When we combine these 4 equations, we got dB proportional to I dl sine theta by r square. To change proportionality into equality, we have to write some constant, that is k I dl sine theta by r square, where k is the constant of proportionality. This constant of proportionality depends upon the nature of medium between the current carrying conductor XY and the point of observation. It also depends upon the system of units used to measure quantities involved in equation 6. Suppose that the medium between the conductor XY and the point of observation P is vacuum or air, and the system of units used to measure the quantities involved in equation 6 is SI system, then the value of K is found to be exponentially equal to mu 0 by 4 pi. Its value is equal to 10 raised to power minus 7 Tesla meter per ampere, where mu zero is the property of a medium, and that property of medium is called as absolute permeability. इसको बोलते हैं absolute permeability, क्योंकि हर किसी मीडियम में एक प्रॉपर्टी होती है कि ये मैग्नेटिक फील्ड कितना इंक्रीज करेगा या कितना डिक्रीज करेगा. वो दिस प्रॉपर्टी इज कॉल्ड absolute permeability, and its value is mu 0 4 pi into 10 raised to minus 7. Now substitute the value of k is equal to mu 0 by 4 pi. In equation 6 we get dv is equal to mu 0 by 4 pi ideal sine theta divided by r square, and this is in fact the magnitude of the magnetic field produced by small current element at point P, where this point P is at a distance r from the center of element. The direction of dB is always perpendicular to the plane containing dl and that of r, and that can be determined by using right hand screw rule. वो किस प्लेन में ideal और dl and r होगा, उसी प्लेन को db हमेशा perpendicular होगा. Now the question is, we have discussed Biot-Savart's law in vector form. If we denote this length of element db by this displacement vector dl, length of r by position vector r, means the distance from O to P by position vector r, and the unit vector along OP, that is equal to r cap. So we can say equation 7 can be rewritten as dB is equal to mu 0 by 4 pi into ideal cross r divided by r square, where ideal it is the current element, r cap it is a unit vector is a vector whose magnitude is 1 and direction is same as that of the given vector. Basically this r cap shows the direction of dB. The question is, why we are showing the direction by unit vector? Because unit vector has magnitude 1, that is why it does not change the magnitude of the given physical quantity. Now, as we know that every vector has two things, one is magnitude and other is direction. तो हमें position vector O to P लिया है, that is R. This vector R has two things, one is magnitude and another is direction. Magnitude is mod of R into R cap. Therefore, from this equation, R cap is equal to R vector R divided by R. Let us call this equation as equation number 9. Now we can substitute equation 9 in equation number 7. Well, we can say dB is equal to mu 0 by 4 pi ideal क्रॉस r डिवाइड बाय r क्यूब, क्योंकि ये r स्क्वायर और जो यूनिट वेक्टर का यहाँ r आया है वो r और ये r स्क्वायर बनेगा r क्यूब. को ये हमने मैग्नेटिक फील्ड, दिस इज द this vector form of Biot-Savart's law, means the magnetic field at point P due to the small element. क्योंकि हमें एलिमेंट का मैग्नेटिक फील्ड नहीं निकालना है, but we have to calculate the magnetic field of whole conductor XY of infinite length. क्योंकि हमें अभी पता नहीं है कि XY की लेंथ कितनी है, तो सर इट इज ऑफ इनफाइनाइट लेंथ. तो हमने किसका मैग्नेटिक फील्ड निकाला है? वी हैव कैलकुलेटेड द मैग्नेटिक फील्ड ऑफ स्मॉल एलिमेंट AB जिसकी लेंथ dl. ये किसका एलिमेंट है? ऑफ कंडक्टर XY. बट एक्चुअली वी हैव टू फाइंड द magnitude as well as direction of magnetic field produced by the whole conductor XY of infinite length. Go to calculate the magnetic field at point P due to this whole conductor XY. We have to integrate equation number 10 over the whole length of the conductor, means integration of dB is equal to mu 0 by 4 pi is constant. It is integral ideal cross r divided by r cube. As we know, integration of dB is b, that is equal to mu 0 divided by 4 pi into ideal cross r divided by r cube. Let us call this equation as equation 12. So equation 12 is the required expression for magnetic field produced by current carrying conductor XY of infinite length at point P. Again, the direction of magnetic field at point P produced by this current carrying conductor is always perpendicular to the plane containing ideal and r, where ideal is the current element and r is the distance from the center of element to the point of observation. The main difference between the electric field and the magnetic field is that for electric field the basic source is electric charge, and while as for magnetic field the basic source of magnetic field is current element. current element is basically the product of current and the length of the small element. This product of current and length of small element is called as current element, and the direction of current element is same as that of the direction of flow of current, and it is a vector quantity. The second point, the main difference between electric field and magnetic field is that for electric field, the basic source is a scalar quantity, while as for magnetic field, the basic source is a vector quantity, because the product of current and the length of element is a vector quantity whose direction is same as the direction of flow of current. So inshallah, tomorrow we'll meet again to the next question, how these uses of Bayes-Servat's law. Thank you.